Hey everyone, and welcome to this video on direct and inverse proportion. Just before we start, I just wanted to introduce you to this idea of the GCSE summer boost that we're running on Twitter. So if you've not already started to follow at Up to Maths, then please do so. We're going to run a question every day between now and the 1st of September, just to kind of give you that extra little bit of a boost, an extra opportunity throughout the summer months to do a little bit of maths every day. The whole point, I guess, in terms of doing it is that you couldn't be together over the last few months. And so if we can do a little bit of work just to try and bridge that gap, then that's what we'll do. All on Twitter. So as I mentioned before, it's at Tup to Maths, and we're going to use the hashtag GCSE Summer Boost each time. Literally one question each day. So nothing that's going to be particularly challenging. What we're going to ask you to do is send in your answers to us, either your individual classroom teacher, or you can post an answer on Twitter, or you can email us, or whatever method you feel happiest with. We're hoping that you're going to find it quite exciting. And I've mentioned this bit already, but at Tup to Maths is what we want you to be following. Okay, let's crack on with what we are doing today. So we've been looking in school at direct and inverse proportion, and this is the recorded version of that lesson. So finishing off Unit 41 or Unit 44, depending on whether you're higher or foundation, it's this little bit here, direct and inverse proportion. What we're going to look at doing is this type of thing to start with. So we're just going to have a quick look at matching up some of the questions and answers here. This is all about direct proportion. So 3 cakes cost 36p, how much do 2 cakes cost, etc, etc. So at this point, just pause the video, give it a go, see how you get on. Okay, and solutions are like this. So the idea with these is you find the price of 1 cake and then scale it up. Find the price of 1 pencil and scale it up, and so on. So hopefully you did well on this one. In terms of moving this a little bit more abstract now, away from the context of that particular question, these are just some numbers. Okay, so we've got some x values, 2, 4, and 20, and we've got some y values, and you'll see that there's always going to be a pair of things that we can do something with. So what we're going to be asked to do is state the equation of proportionality and then sketch a graph. Well, the equation of proportionality is simply the relationship between the x variable and the y variable. So we can see that 14, if we divide it by 2, we get 7. Or you can think, what do I times this by to get to this? And so y is 7 times as big as x, or y equals 7x. We can then start to put in the extra values. So if x is 4, y is going to be 7 times as big. If x is 20, it's going to be 7 times as big. And this time to go from here back, we are dividing by 7 this way to get to 8. And then we've got ourselves a set of coordinates. So we can start to draw this out on a graph. And if it's direct proportion, we are going to get a straight line graph. Okay, so you plot your points like this, you draw it, and it says use the graph to estimate the value of when y equals 32. So you find roughly where 32 is, you draw a line across, and then you read off when it touches the graph, you read off reading down. So in this case, it's about 4.5. Okay, so we're using it to estimate it. Now we could use a more formal algebraic way to do this, so we don't have to draw a graph at all, and we'll have a look at that in a minute. Here's another question for you to have a little go at by yourself. So I want you to think about what we're doing to get from here to here. Use the same idea, and then we'll put in some answers in a second. Okay, so you can see that it's 5 times as big. So we start to put in our 5 lots of. So Q is 5 lots as big as, 5 times as big as P. So we've got 100, we get 5. And then going back this way, we're dividing by 5. So 15. Draw a graph, see what happens. Again, you only need a couple of points with a straight line graph. As long as it goes through those, you'll be absolutely fine. And then we want to estimate the value when P is 9. So again, you find P, 9, you draw yourself a line up to the graph, you read off and see what it says. So in this case, 45. Okay, a little bit of note taking then. So two quantities are said to be in direct proportion if they increase and decrease at the same rate. So if the ratio between the two quantities stays the same, like all the ones we've just seen, it was the same value each time. Two quantities are said to be inversely proportional if one thing increases, the other thing decreases at the same rate. Okay. So let's have a look at how we might do this in a little bit more algebra then. So we start moving away from the graphs and just looking at it algebraically. So this is the applying section over here. So directly proportional means that it is increasing. Okay, so y equals something x. And what we're going to do is we're going to try and work out what this something is. Now, in the last couple of examples, we were given some numbers straight away so we could see. And so when we start to do these things, you will always be given some numbers and you have to work out what this constant of proportionality is going to be. So all it's saying here is that y is something times by x. If y is inversely proportional to x, then what's happening here is one's going up, the other's going down, and y is k over x, or k lots of 1 over x. So in this case, k is being divided by x. Okay, so the important thing is when we're doing the questions, we look out for these words and then we write it in this particular way. A good way to practice that, just looking at the words and making sure we can set up the algebra first, is to do this little bit of a matching task. So again, I'll show it, I'll put it on screen, you can have a go, and I'll reveal the answers in a second. Okay, so we've got some word statements, we've got some algebra statements. Your task is to try and match up the words to the algebra. So y is directly proportional to x. I'll give you that one as a starting point. So if we were going to do that one, and say you can either highlight it, you can number it, whichever way you want to do it. Y is directly proportional to x. I'm trying to find y equals kx. Here it is. So y equals kx. Those two things match up. Okay, so have a go at the rest, see if you can do it, pause the video, and then I'll show you some answers in a second. Okay, and here are the solutions. So as I previously showed you, y is directly proportional to x, matches up to y equals kx. Inversely proportional to the square root. So remember, inversely proportional means it's a fraction. So you've got k over the square root of x. Instead of proportional, you might see the word varies. Now, varies inversely is the same as inversely proportional. Okay, so have another look through, make sure that you've got yours matched up appropriately. If not, make sure you understand why, and then you can always drop a quick message out to me or your normal maths teacher asking for a little bit of help if you're not sure on why some of these things are what they are. Okay, let's have a go at a step-by-step guide then, actually doing some of this algebra manipulation. It might be quite useful to do. So the first thing we're going to do is write the proportion sentence, just like we've just done. We're then going to find the value of k, a bit like we did in that starter. We're then going to rewrite the proportion sentence with the k being the number, and then we're going to do the simple bit of algebra to answer the question. Let's actually have a look at one of these. I think it'll make more sense if we actually do one of these questions. Okay, so let's actually have a go at a question. It says W is directly proportional to F, and when F is 24, F equals 6. Find the value of W when F equals 10. The first thing we're going to do is make sure we've got our algebra statement written out, just like we did in the previous task. So first of all, we can say W is directly proportional to, so W equals KF. Next step is we need to work out the value of K. So we know some numbers. We've got a pair of numbers, again, just like we had in that table at the very beginning. We need to work out what we can do to F to get to W. So what do I multiply F by to get to W? And so we set it up like this, and we can see that K has got to be 4. So we've got ourselves an equation of proportionality. W equals 4F. Next step is we then use this value. So W equals 4F. We know that F is 10, which means that when you substitute it in, we get W equals 40. And so we're always going to do these questions in the same way. You set out your, or you basically turn your words into algebra, you substitute your numbers in, you find your k, and from there you put your other value in when you know k, and you work out what w is. So you'll be given a pair of numbers, you work out k, you've given the other number to work out the final value. Let's have one more go. So g is directly proportional to the square of h. And when g is 100, h is 5. Find h when g is 64. So we're not going to do anything with this bit just yet. We're going to turn our sentence into some algebra. So g is directly proportional to the square of h. G equals k h squared. We've got a pair of numbers, so let's put those in. So 100 is k times 5 squared. So I've changed my h to be the value that I've been given, and so on. Which means that 100 is 25 times k, and in this case, k is 4. So just coincidence that k is 4, it's not always going to be. I know the last example was and this one is, but like I say, coincidence. We've now got ourselves a formula we can use, and it says that g is 4 lots of h squared. We're finding the value of h when g is 64, so pop your numbers in. So 64 equals 4 lots of h squared. To work out what h squared is, divide by 4 and then square root it. So h in this case will be 4. Okay, at this point what I'm going to suggest that you do is have a go at a few of these. So pause the video at this point, give it a go. Notice these are all direct proportion. Answers will follow shortly. Okay, and here are some worked solutions to each one. Again, pause the video, mark, make sure you're getting the right answers. Then these ones are inversely proportional. So we're going to do exactly the same thing. We're going to set it up. So in this case, D is K over W, inversely proportional. Let's put the numbers in. So 3 is something over 9. Remember, when we've got something like this and we want to undo this divided by 9, we multiply. So K is 27. We then set it up. So we've got D is 27 over W. We want to find the value of D when W equals 3. So when W is 3, D is 27 over 3. D is 9. Okay, so we're doing exactly the same steps each time. The setting it up in the first place is the difficult bit. Okay, one last one. R is inversely proportional to the square root of f, and we've been given some values. So we set it up. R is so inversely proportional to the square root. Here we go. Substitute your numbers in. Work out what your value of k's got to be. Remember, if you've got a number down here, you're multiplying it up. So k is 128. Here you've got your formula. We're trying to find out what f is when r is 16. So change your r to be 16. Okay, now this is a little bit tricky. So when it looks like this, what I tend to think about here is just swapping the two things over. So if you multiply by root f and you divide by 16, these two things end up swapping. Okay, so it's quite a nice, easy way to do it. And so root f equals 8. So f is going to be 64. To undo the root, you square it. Okay, fab. 4 questions for you to try on this then. Again, pause the video, give it a go. Answers will appear shortly. Here are the solutions. So I say go through, mark them, see how you get on. And then as a final little bit of a review question, it might be worth just checking that you're happy doing this. So if you've got a little table like this and you want to work out what these values are, then you can give it a go in your own time. Finally, last thing I wanted to say, make sure you've checked class charts this week for the rest of the work that's been set. I think they might, certainly if you're doing higher, I know I've set some lockdown papers this week, so have a go at those and try to get involved in the Tupton Maths Twitter campaign with hashtag GCSE Summer Boost all through the summer. Thanks very much for watching and I'll see you soon. Bye.